Welcome back, dear students. In this video, we are going to continue part 2 of chapter 2, Superposition of Waves. But before, let's remember what did we learn in the previous part of this lesson. 1. Wave is a periodic motion that transfers energy but not mass or matter. 2. Wave, according to the type, can be longitudinal or transverse. According to the nature, can be mechanical or electromagnetic. Wave is characterized by its amplitude, its period, its frequency, its wavelength, and speed of propagation. At the end of this video, you will be able to identify points vibrating in phase and out of phase or antiphase. Consider a juggler who throws two small balls using his two hands. If the two balls reach their highest points and lowest points simultaneously, then the balls are said to be in phase. In the other case, if the first ball reaches its highest position and the second one passes through its minimum position, then these 2 points are said to be out of phase. The motion of these balls is very similar to points vibrating in a certain medium due to a disturbance. So now let's define points vibrating in phase and out of phase. What's in-phase points? If 2 points have the same vibratory state, then they are in phase. They reach their highest position and their lowest position simultaneously, and they have the same direction of vibration at any instant. What about out of phase? If 2 points have opposite vibratory state, then they are out of phase or antiphase. One reaches the highest position, and at the same time, the other reaches its lowest position. Also, they have opposite directions of vibration at any instant. Let's take this example. The points A, B, and C are vibrating at the same time. This screenshot of the wave shows that the points A and B reaches the crests or the maximum position at the same time. Then the points A and B are said to vibrate in phase. What about the points A and C? The points A and C vibrate out of phase because when point A reaches its maximum, point C reaches the minimum. Point A is on a crest and point C is on a trough. The same thing is for points B and C, which vibrate out of phase. Notice that these 3 points vibrate on the same wave at the same time. The points A and B are in phase because they reach the maximum and the minimum together or at the same time, whereas point C is out of phase with respect to A and B because when C reaches the maximum, B and A are at the minimum, or when C reaches the minimum, A and B are at the maximum. How can we study the vibratory state of the points by calculation? In case of a wave produced by a continuous source of vibrations, let's take some points which are in phase and find the distance between them. We notice that the distance between the points A and B is equal to lambda. The distance between the 2 points A and C is 2 lambda, and the distance between the points A and D is 3 lambda. What can you notice about these 3 distances? What is the common between them? Let's conclude. 2 points on the same wave ray are said to be in phase if the distance between them is D is equal to K lambda, where K is a natural number. Or we can say that the distance between any 2 points in phase should be a whole multiple of lambda. What about points which are out of phase? Let's take the distance between some points which are out of phase. For example, A and M. The distance between them is half lambda. The distance between A and N is 3/2 of lambda, or 3 lambda divided by 2. The distance between M and D is 5 lambda divided by 2. Can we write these distances in another form? Of course, yes. We can say that lambda over 2 is equal to 0 plus half all multiplied by lambda. If we find the common denominator of these two fractions, then we will have 2 into 0 plus 1 divided by 2 multiplied by lambda. The same for the distance between a and n, where it will be written as 2 into 1 plus 1 divided by 2 times lambda, and same for the distance between m and d, which will be 2 multiplied by 2 plus 1 over 2 divided by lambda. What can you notice? What is the common between these forms of the distances? Let's conclude. 2 points on the same wave ray are said to be out of phase if the distance between them is d is equal to k plus half all multiplied by lambda, which is equal to 2k plus 1 divided by 2 multiplied by lambda. And we know from mathematics that if k is a natural number, then 2k plus 1 is an odd number. Then the distance can be written as odd number divided by 2 multiplied by lambda. What if these points are not in phase and not out of phase? Let's take some examples. For example, the distance between a and x is 3 lambda over 4. The distance between x and c is 5 lambda over 4. The distance between a and z is 7 lambda over 4. Are these distances similar to the distance between any 2 points in phase or out of phase? Of course not. So we conclude that these points are not in phase and not out of phase because the distance between them is not a multiple of lambda, and it is not equal to an odd number multiplied by lambda divided by 2. What about the case of two waves? When do we say that they are in phase or out of phase? For two waves to be in phase, then the crests of the first wave should overlap with the crest of the other wave. Same for troughs, they overlap. Whereas, if two waves are out of phase, then the crests of the first wave overlap with the troughs of the other wave. Let's now check our understanding by solving application number 1. The point S of a vibrator strikes the surface of a liquid with a frequency equal to 15 Hz. Knowing that the speed of propagation of the wave at the surface of the liquid is 45 cm per second, determine the vibratory state of the points A and B on the surface of the liquid that are collinear with S and situated respectively at 6 cm and 10.5 cm from S. Try to solve it alone first, then check the solution. First of all, we have to find the wavelength of the wave, which is lambda is equal to V divided by F, which is equal to 45 divided by 15 is equal to 3 centimeters. Then we have to find the distance AB, which is equal to SB minus SA, 10.5 minus 6, which is 4.5 centimeters. Then we have to divide this distance by lambda, which gives 45 divided by 3, which is 1.5, and we all know that 1.5 can be written as 3 divided by 2, which is equal to an odd number divided by 2. If we cross multiply this equation, then we will have d is equal to an odd number divided by 2 multiplied by lambda. Then we conclude that A and B vibrate in antiphase or out of phase. Let's now sum up all the ideas that we have explained in this video. 1. If two points have the same vibratory state, then they are in phase. 2. If the 2 points have opposite vibratory state, then they are said to be out of phase or antiphase. 3. 2 points on the same wave ray are said to be in phase if the distance between them is d is equal to k lambda, where k is a natural number. 4. 2 points on the same wave ray are said to be out of phase if the distance between them is d is equal to k plus half all multiplied by lambda equal to 2k plus 1 divided by 2 multiplied by lambda, which is equal to an odd number divided by 2 multiplied by lambda, where k is a natural number. Thank you for watching. Prepare yourself for part 3 and the last part of this lesson.